All right, so they give you that x is equal to 4 is a 0, and then you want to find the remaining zeros. So the first step is that because we cannot factor this, again, when we're given a polynomial, we can say to ourselves, let me try to factor it. In this case, we cannot factor it by grouping because when we look at the first two terms, there's absolutely nothing in common that will also be in common to the last two terms. So that leaves us with synthetic division as our only means to find the other zeros. So for synthetic division, we will start off by writing out the polynomial's coefficients 2, -9, 3, and 4. And then to the left of the L, we plop down the 0. So we just write the 0 of 4, no change of signs. So we bring down the 2. We multiply diagonally the 2 times 4 to give us 8. Add vertically to get -9. Multiply diagonally to get -4. Add vertically to get -1, multiply diagonally to get -4, and here's where the beautiful thing happens. When we add vertically, we get 0, and that 0 indicates to us, this remainder of 0, tells us that we have done this correctly and that the number to the left is in fact a 0. So this verifies for us that x is equal to 4 is a 0. Now, the whole thing about doing synthetic division is that we want to kind of reduce the power of the polynomial we're dealing with. So we couldn't solve the 2x cubed equal to 0 polynomial. But now that we've done synthetic division, we're now working with, because it was x cubed, one less, we're working with an x squared polynomial. So we have 2x squared minus x minus 1, and now we're trying to solve that equal to 0. So we take our current quotient, we set it equal to 0, and see if we can solve. Now, because it's a quadratic equation, we have two methods potentially that we can use. We can use factoring or the quadratic formula. So the easiest method usually is to try to go through the factoring method. So we think about the factors of the first times the last. So two numbers that multiply together to give us -2 and sum up to give us -1. And in this case, -2 and a +1, if I multiply those two together, I will get the -2 that I need. And if I take -2 plus 1, that will give us the -1 that I need. So this tells us that our winning combination, so to speak, is this -2, 1. Now, we cannot just plop that down, though, because of the fact that we have a 2x squared rather than a 1x squared. So what we'll have to do is take our 2x squared minus x minus 1 equal to 0 and split this up based on that winning combination. So the -2x plus x minus 1, and then the 2x squared. And then from there, we will do our grouping method. So from the first two, we can bring out a 2x. That leaves us with x minus 1. And then from the last two, we will have x minus 1 if we just bring out a placeholder 1. Now that we have the x minus 1's common, we bring that out, and we have 2x plus 1 equal to 0. So we set each of these factors equal to 0 now. We get x is equal to 1, and then we get the 2x plus 1 equal to 0. Solving that, we get x is equal to -1/2. So those are the other zeros. We have 1 and -1/2 as our other zeros. Okay, and so keep in mind the synthetic division process, the whole idea is that you're reducing the polynomial, the order of polynomial that you're dealing with, until you get down to a quadratic. And once you get down to a quadratic equation, then you can either factor or do the quadratic formula.